If it finds it to be true, the particle will be sent out to the next event, and so on. Below the test value, you can see we have a variation value, and this works in exactly the same way as variation values do in most of the other tests in particle flow. In other words, there's a positive and a negative modifier to the actual test value. And then below that we have the sync by flyout. Just like many other operators, again, the sync by flyout is used to actually synchronize any animation which is used on the test value, for instance, to synchronize that with the actual particle. And you've got a choice of using absolute time, which will actually synchronize that animation with absolute time. So in other words, if you animate this value, the test value, from say frame 0 to frame 50, absolute time will actually apply that animation from frame 0 to frame 50. If you use particle age, that will be based on the particle age. So if the particle is born on frame 20, that animation will be applied to the particle from frame 20 to frame 70. And then finally we have event duration, and that's based on the time that the particle actually enters the event. So if it were to enter the event on, say, frame 50, then our original animation, which was done from frame 0 to frame 50, would actually take place now from frame 50 to frame 100. So you've got those three options to actually choose how the synchronization takes place. Okay, so let's actually put this back to where we had it before, which I think was velocity on Z. There we go. And you can see we're actually using a test value here of -95. Now this test is actually active at the moment, so if we actually play, we'll see what happens in this particular circumstance. There we go. So we see our particles are fired up into the sky, as it were, and they decelerate because of gravity. And when they start falling down, when they reach a certain speed, you can see they actually meet the criteria for the test. They're sent to the next event, and they explode into a bloom of fireworks sparks. Now, if we turn off this test, and we turn on the next test, which is this one here, we have a look at the criteria for this, we can see that in this case we're actually testing for less than the test value. And the test value is 159. So what's going to happen here is our particles are actually going to shoot upwards with a certain speed, and gravity is going to start to slow them down. And before they actually reach the apex of their arc, we're actually going to test to see if they actually drop below this speed here. And if they do, we're going to send them on to the next event where they actually explode. So let's see if that works. And you can see, yes, it does. Now, if I move up to the point where they explode, and I reduce this value, you'll find that you can see the particles are actually exploding a little bit at a different point in time. There we go. So now if I play it, you can see they actually explode a little bit later. And if I drop it even more, there you are, you can see the blooms are moving up. There we go. And now if I actually play it, there you go. Incidentally, a side effect of actually what we're doing here is that if you look at the spawn particles, you can see that they're inheriting some of their parent speed, and then they get sent down to here. You can see we're using some divergence here, and they're sent down here into this particular event, and they're actually sent off in various directions. Now, one of the things that's actually happening is that if we look at this test here, you can see that if you actually change this value, you can see that the actual bloom changes shape somewhat. So if we actually move it backwards, you can see it's actually getting larger. So it's actually getting more of its parent speed if we move it backwards in time. That's because as we move it back in time, the point at which we're testing the particle, the actual particle has more speed. So it explodes at a point where it actually has more energy, and more of that energy is actually passed on to its bloom. So that's quite an interesting effect of it. So that's it basically. That is the speed test. You've got all these different options here for actually testing out your speed. I'd recommend loading up this test file, have a quick run through all of the different options that you can see here, try using the speed test that we have here, try using different values, different combinations, putting in, as you can see in this particular example here, I've actually used negative values. Try using negative values, and try varying the less than and greater values. Obviously this particular scene is set up where most of the action actually takes place on the z-axis, but you could actually just rotate this source here, and then obviously you'll get more action taking place on the x-axis and also the y-axis. So that's it for the speed test. Let's move on now and have a look at the next test, which is the split amount test.